guys, hope you're doing great. Today's question is best time to buy and sell stock 3. So the question says, say you have an array for which the ith element is the price of a given stock on day I. Design an algorithm to find the maximum profit. You may complete at most 2 transactions. You may not engage in multiple transactions at the same time. That is, you must sell the stock before you buy again. So this is pretty standard. That is, we cannot hold more than one stock at any point in time with us. And the added constraint here is that we can complete at most 2 transactions, which means that we can also do just one transaction, right? So that's also a possibility. So for example, here the output is 6 because we buy on the day 4 and sell on day 6. So that's the profit. And then we buy on day 7 and sell on day 8. So we're basically finding 2 combinations here, right? One is the first buy and the first sell, which gives us the maximum profit. And relative to that, the second buy and the second sell, which gives us the maximum profit. And similarly here. So here, this is 1 and 5, it's an increasing sequence, and we just make a single transaction because we get the maximum profit by doing that, right? So and since this is decreasing, so there's no way we can make any profit, so that becomes a 0. Okay, so now talking about how to approach this problem. So as I was saying that we need to focus on 4 values, right? One is the first buy. Okay, so yeah, so one is the first buy, okay, and the first sell, right? So we need to make sure that we maximize the profit we earn from this transaction. So now it could be possible that one might just traverse through the whole array once and find the min and the max, and that could be the first buy and the first sell, sure. So if it's a case like 1 2 3 4 5 here, then there's only one transaction that needs to be made, then that thing will work, right? But if we want to make 2 transactions and the array is such that 2 transactions reveal more profit, in that case we will end up catching the minimum and the maximum value, and since in between those 2 values we can make no more transactions because at any point in time we can hold just one stock, right? So we would be devoid of the other opportunity of making more profit, that is by doing a second buy and a second sell. So that helps us understand that these values are interdependent, okay? So, and the final answer, right? So it's really important to understand that, for example, I am buying a stock, right? So the first buy means the amount of money that is left with me after I purchased this stock. So we want that to be maximum. So what I mean by that is, let's say, for example, if there is a stock of price 1, okay, and there is a stock of price 10, and we have 100 rupees with us, okay. So 1 and 10, these are the 2 stock prices, and we have got 100 bucks with us. So if we buy it at 1, right, so we'll have to pay 1 to buy that particular stock, and what we'll be left with is 99, correct? And if we buy the one at 10, we'll have to pay 10, so what we'll be left with is 90, right? So in order to ensure that we buy at a lesser price, right, we need to maximize the amount of money that is left with us after buying, correct? So that is why we want to maximize the first buy, maximize the first sell, right? And similarly the second buy and the second sell, and then at the end, after completing these 4 transactions, whatever is left with us is our profit, right? So I hope this makes sense, and that is the reason that we cannot compute them separately. We need to compute them in one go, and at every day we need to find out that if at this day I take this as my first buy, then what will be the impact? So I just pick the whatever first buy I have computed till now, or the first buy from this point. Okay. Similarly, first sell, second buy, and second sell. So I just understand the effect of that particular price on that day on all these four values, and then we have a final second sell, which is the maximum. So we'll just try to implement this and see. Okay, so if prices dot length is equals to 0, then we can just return 0. Okay, and fine. So we'll just need four values. We'll just take first buy. Okay, and we'll just assign them some really small values. So we'll just say that it's min value. Okay, and we'll also assign the second buy integer dot min value, because we want this to be initialized in the first go, and our first sell is equals to 0, and the second cell is also equals to 0. Okay, now we'll just start from I equals to 0, I less than prices dot length, and I plus plus. Okay, and for first buy we'll say that, okay, first buy equals to math dot max of first buy. Okay, whatever we have done in the past and whatever value is the maximum value we have been able to get for the first buy in the past, either that, or since this is going to be the first of this whole streak, right, then just the negation of prices of I, because we are saying that we don't have any money at this point in time. All we are doing is we are just paying. That's the first transaction. So since we are buying, we are paying, and we just do a negative of prices of I. Okay, first sell. So after doing the first buy, we will come over to the first sell, right? So either the pre-computed value, if that's more, or if we are selling the stock we purchased at this price, the first buy, then we can say that, okay, so this is going to be our price on which we will sell it, right? And what we have is first buy, right? So after buying, whatever money we are left with, we will, if we sell it at this price, we will add that price value to that money, and what we are left with is first buy, right? So after buying, we are left with some money, right? Then if we are selling this, so we add this price because we have got some money after selling it to the first buy. Okay, then with second buy we have to do something similar. So either second buy, or now here we don't have to start with this because this is not a first transaction. So what is the amount of money that we have right now is the first sell, right? So first sell, and since we are buying, we have to pay, correct? And then second sell equals to, similarly, either this same value, or we just, the recent amount of money that we have is the second buy, so that plus the prices of I. Oh, sorry. Okay. So this way we will be able to, in a relative manner, compute all these values, and then at the end we just have to return the second cell, because that is the ultimate profit that we will be able to make. So let's see if that works. Um, oh, that's weird. Uh-oh. Yeah. Okay. Yeah, that works. So the time complexity for the solution is O of n, because we're just traversing the prices array once, and the space complexity is O of 1 because we're just using 4 variables. So I hope you guys find this video helpful. If you do, please like, share, and subscribe. Keep coding. Take care, guys.